While some quadratic equations can be solved using factoring, many can't. For the ones that we can't solve with factoring, we need to turn to the quadratic formula. The quadratic formula is just an equation that lets you find the solutions of quadratic polynomials, as long as those polynomials are written in standard form. They'll help us to find solutions when we can't factor, or when we're having trouble factoring. We can use it for that as well. The answers for these we'll leave either in radical form, so we'll simplify the radicals and reduce the fractions if possible, or we can just leave the answers in decimal form. The answer we're looking for, the mode of our answer, will depend entirely on the application. For us, the questions will guide us as to which type of answer, which form the answer should take. This is what we mean by an equation in standard, also called expanded form. We have an x squared term, an x term, and a constant, and we've set these to 0. If there's a value other than 0 on the right-hand side, the first step would be to move it to the left-hand side. So if we've organized it so that the x squared term is first, then the x term, then the constant, then we label their coefficients, or the constant, as a, b, and c. A is the number in front of x squared. B is the number in front of the x, and c is the coefficient. Now, we don't have to isolate x here. It's already been done for us. It turns out that in order to isolate x, we have to take the numbers a, b, and c and organize them in this way. We could walk through this, but it's been done, so we may as well just use it. We're just going to fill in the values for a, b, and c in the quadratic formula, and that lets us solve for our unknown. Let's see what that looks like. Because all equations that are quadratic, that have a term with an x squared as the highest power, have two answers. You see here that we'll get two answers from this formula. The first answer is the value of negative b plus the square root of b squared minus 4ac, all divided by 2a. And the second answer is negative b minus the square root of b squared minus 4ac, all divided by 2a. So this plus minus notation is just a compact way of writing two different answers. Here's our first example. As a reminder, the quadratic formula is up in this right-hand corner. Our first job then is to identify the values for a, b, and c. Well, a is the coefficient of x squared. So for us, a is equal to 3 in this question. B is the coefficient for x. So here the value of b is negative 8. And finally, the constant is our value for c. So here c is equal to negative 4. So let's write out the quadratic formula. X is equal to negative b plus or minus the square root. It's a large square root. Everything I say next has to fit under it. B squared minus 4ac. And all of that, not just the radical, not just the b, is divided by 2 times the value of a. Substitute in the values for a, b, and c that we listed up here. All right, so x is equal to negative b. So negative whatever the value of b is, and b has a value of negative 8. Plus or minus the square root of b squared. So we'll take b has a value of negative 8 and square it. So we have to be careful that it's not just negative 8 squared written without brackets. We want to square the entire value of b. So we have to put brackets around the negative 8. Remember that negative 8 squared will give us negative 64, where negative 8 in brackets squared will give us the value of positive 64. It's the value of positive 64. That's the correct answer in our case. All right, we keep going. Minus 4 times a. Our a has a value of 3 times c. Our c is negative 4. Let's make sure we extend that radical far enough. All of that is divided by 2 times a. For us, that's 2 times 3. All right, so x is equal to negative times negative 8, so negative 1 times negative 8, or positive 8, plus or minus the square root of 64, minus 4 times 3 times negative 4. So we have negative 4 times 3 times negative 4. We have two negatives. That gives us a positive value. 4 times 3 times 4 is 48. So negative 4 times 3 times negative 4 is positive 48. And all of that is divided by 2 times 3 or by 6. Order of operations tells me we have to simplify inside the brackets first. So we have 8 plus or minus the square root of 64 plus 48, which is 112, all divided by 6. Now, I could reach for my calculator at this point, but this particular question asks us to leave the answer in radical or exact form, which means that we might be done. Or perhaps we can simplify that radical. Well, the square root of 112, can that be simplified? Turns out 112 is divisible by 16. That's the largest perfect square that goes into 112. 112 divided by 16 gives us 7. You can rewrite this as the square root of 16 times the square root of 7. The square root of 16 is 4. So we've simplified the square root of 112 to give 4 root 7. So let's fill that in. So we have x is equal to 8 plus or minus 4 times the square root of 7, all divided by 6. Now I notice that looking just at this numerator, that I have two terms and they have a common factor. Both the 8 and the 4 root 7 are divisible by 4. So I'll pull out the common factor. We get x is equal to 4 all times 2 plus or minus the square root of 7 divided by 6. Now I have one term in the numerator and one term in the denominator, which means I can simplify. 4 and 6 reduce to 2 over 3. They're both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So my final answer is 2 times 2 plus or minus the square root of 7 divided by 3. And we'll leave it in this form. This is the exact answer to this problem.